Hello, dear students. Welcome back to your math classes. How are you all? I hope you all are healthy and doing well. So, students, I'm your mathematics educator again here with a new chapter and a new concept. And today we have chapter number 10, which is understanding elementary shapes. So, in a previous chapter, we already learnt about different polygons, right? That we call them shapes. Now we are going to understand about those elementary shapes which we have to go through according to our syllabus in class 6. So, introduction, first of all, we have in the previous chapter, you have learned about the basic concepts of geometry like point, line, angle, polygon, triangle, quadrilateral, and circle. So, the next step is to know more about them, their sizes and measures, and you will also learn about classification of angles, triangles, and quadrilaterals. So, in previous chapter, we already we already learned till about point, line segments, and uh, the shapes which we made from line segments, and a shape we have which is made from curves. So now we are going to learn about in detail about those polygons. So here we have, so first of all, we have comparing line segments. So I hope you remember what is line segments. By observation, if there is a marked difference in the lengths of two line segments, you can judge it by merely looking at the two segments. So, for example, if you have a long line and you have a small line, so by observing according to their length, you can easily classify that, okay, fine, these two lines are differ to each other. One is smaller and one is longer. In the figure above, clearly CD appears longer than AB. So we say CD is greater than AB. In the joint figure, PQ is lesser than RS. So for the adjacent figure, you cannot decide which of the two segments AB or BC is longer by simply looking at the figure. So there is a moment when you cannot tell us by observing which one is longer and which one is smaller. So what we have to do? So we look for another way to compare two line segments. So we have to use some another ways to measure the measurement of these lines. So the first thing, we have a thread. So you can easily take a thread, point out from initial point and end point of a line segment, and then you can measure which one is covering more length of the thread, and after that you can easily write which one is longer. Now we have the third method, which is by tracing. So consider two line segments AB and CD. With the help of a tracing paper, trace line segments AB. Now place the tracing paper so that end point A lies on C and AB and CD lie on the same line. So when you have a tracing paper, you trace your line AB, and when you overlap to the CD, so if the line extends towards the CD, you can simply say that, okay, CD is greater than AB, or if the line it's not extended further, so you can simply say AB is greater than CD. So I hope so this method is clear to you, and this is very easy method which we do in our earlier classes in a playful way. Now we have to use by using our divider. So divider is your compass basically. No, divider equipment like compass basically, but in this section there is a no place for holding a pencil. That is why it is called a divider. You can simply open your divider and put a pinpoint, the starting point to A and the ending point to B. After that, the same measurement you have to place on the CD if the line is smaller. If the opening point, the mouth of a divider is smaller as compared to CD, it is simply says that CD is greater than AB. So put the pointed head of one arm of divider on the end point A without moving this end point, the divider, and adjust it so that its second end lies on B. Now lift the divider and without disturbing its arms, place it on CD so that one end is on C. If the second end lies in the between C and D, then AB is smaller than CD. If the second hand is ahead of D, then AB is greater than CD. So which one you can easily classify after taking your divider mouth, and you can easily say that which one is greater, which one is smaller. Now the real method to measure your line segment is your rule, right? By helping your rule, you can easily measure length of any line segment, and then you can tell me or anybody else that which one is greater or which one is smaller. So for example, first of all, we have to start with it using rule. Usually a rule has centimeters and milliliters marked on one edge and inches on the other edges. So nowadays centimeter means meter, centimeter, millimeter are used to measure length, and we already know in our earlier classes in class 5th about the standard units of measurements, right? Have you remember that? Okay. So now 1 meter is equal to 100 centimeter. Well done, students. And 1 centimeter is equal to 10 millimeter. To measure the length of a given line segment AB, the ruler is placed so that its edge lies along AB. Simply what you have to do, you have to put your 0 to the initial point of A, and you have to see where your line ends. Here your line ends at B, and at B you measure what? 6 centimeter. It means AB is equal to 6 centimeter. Same process you have to do for the next line, and after you have done that, this activity when you complete it, so you have two measurements, and according to measurements you can simply write your answer, which one is smaller, which one is longer. Now using rural and divider. Now we are using both the things, divider as well as the rural. So a divider and a rural may be used together to measure a line segments. Open the divider and put the pointed end of one of the arms and point A of line segments AB. Without lifting the arm placed at A, adjust the other arm of the divider so that it pointed and lies at end point B. What you have to do, your open mouth you have to measure with the help of your rural. Okay, you measured with the divider AB, and this much your mouth is open. Now you have to put this mouth from 0 and see where it's end. So it's end at 5.5. It means AB measurement is 5.5 centimeter. Now we have our exercise 10.1. With the help of a divider, compare the following pairs of line segments. So I already explained you each step about measurement. So you can simply use your divider and measure this length and write your answer. With the help of a divider, compare length of a sheet of your mathematics book and length of a sheet of your notebook. So you can do that also. Length and breadth of a postcard. So students, what you have to consider in this exercise, that almost questions are practical. So you have to do it your own. So just make sure you have your equipment and you can follow the step as I explain you in your above section, and then you can complete it. Now with the help of a thread, compare length and breadth of your study table. You can do that also. Now we move forward, draw a triangle DEF. With the help of a ruler, measure DEF and DF, compare. So you can do this also. What you have to do, DE plus EF. So you have to consider that the two measurements, the two sides measurement should be greater to the third side of the triangle. For example, if you make a triangle like this, is 2 centimeter or is 3 centimeter, then you have to make sure that it should be 4 centimeter. So what will happen? 2 plus 3 is equal to 5, which is greater than your side third. So you have to make, and you have to take some random measurement like this, which is always considered at the measurement of two sides of a triangle. It's not greater than the third side. It should be greater than the third side. Now, if F, G and H are three collinear points such that FG is equal to 9 centimeter, FH is equal to 3 centimeter and GH is equal to 6 centimeter, then which points lies between the two? So, which points lies between the two? So, this is your 9 centimeter, 3 centimeter and 6 centimeter. So, you all know that collinear points means points in a straight line. So it should be 3 centimeter, 6 centimeter and 9 centimeter, just because while you make a line like this, then you have a measurement of 9 centimeter, then your FG is equal to 9 centimeter. So 0.6 would be lie between these 2 points. Next we have magnitude of an angle. In the previous chapter, you have learnt that an angle is figure form two rays having the same initial point. We already do this portion in our earlier classes, in our previous chapter as well. So you can also look upon angle AOB being formed as a result of rotation of arm OA in the plane about point O. From its initial position OA to find position OB, magnitude of an angle is the amount of rotation through which one arm of an angle is rotated about the vertex to bring it to the position of other arm. The movement of this ray, the movement of OB. Okay, for example, your angle is like this. Okay, and this is your OB, and you have to move this like this. It could be not move like completely, but you have to understand this. Okay, this OB will have rotation point to measurement. Magnitude, you can also say that according to magnitude, we can classify the measurement of an angle. So, for example, classification of angles. Angles are classified according to their magnitude. As I already told you that angle is defined with the help of its magnitude. Complete angle. If rotation say OA makes a complete rotation, for example, it's make a complete rotation about initial point O and come back to the original position, then the angle form is a complete angle, and complete angle is referred as 360 degree. Okay. Next, straight angle. If the ray OA rotates about O and takes the position OB such that OA and OB are opposite to each other, now your angle will be like this. It is forming a straight line. Okay. Like ये तो नहीं होगा, but you have to consider like this. It will be a straight line like your figure. This ray is moving shifted to this side. That is why it is forming a straight line, and when we have a straight line, it means we have an angle of 180 degree, and it is formed on a straight line. That is why we called it a straight angle. Now, right angle. If a ray OA rotates about initial point O from horizontal position to reach the vertical position OB, makes a quarter rotation, then the angle formed is a right angle. Then when you have a angle like this, it is referred as your right angle, and right means 90 degree, or you can say that 90 degree means right angle, so it is vice versa. Now we have zero angle. If the initial and final position of a ray coincide without making any rotation, the angle form it's called zero angle. Degree measure of a zero angle is 0 degree. Now we have acute angle. An angle whose measure is greater than 0 degree but less than 90 degree, it's called an acute angle. It should be greater than 0 degree and it should be less than 90 degree. That is why the movement you see here, it is less than 90 degree. Now we have this less than 90 degree, because 90 degree is equal to this and your ray is still shifted towards the opposite side of the 90 degree. That is why it's your acute angle. Next we have obtuse angle, which means greater than 90 degree and it should be less than 180 degree. That is called your obtuse angle. An angle whose measure is greater than 90 degree but less than 180 degree is called an obtuse angle. Now we have reflex angle. An angle whose measure is greater than 180 degree but less than 360 degree is called reflex angle. So what you have to do here, first of all, while you seeing this video, you have to take a sheet of paper and name these angles, and you have to classify. Okay, right angle, less than right angle we have acute angles, and more than 90 degree means obtuse angle. The angle lies between more than 90 degree and less than 180 degree, that is your more than 180 degree but less than 360 degree, that is your reflex angle. So you have to make your notes, and after that you can consider. Okay. So after this you have your a combined form of all your angle information in your page. Now we have geometry of a clock. So now we are going to understand geometry with the help of a clock. Look at the two hands of a clock. When it is shown 3 o'clock, the two hands form a right angle. We have two numbers between 12 and 3. Okay, these are 1 and 2. These two numbers divide the space between 12 and 3 in 3 quarters parts, 3 equal parts. Angle subtended at the center by each part is equal to 90 divided by 3 is equal to 30 degrees. Since numbers on the face of a clock are spaced uniformly, your movement of a hand from one number to the next covers an angle of 30 degrees. For instance, let us find the angle which the hand of a clock moves when it goes from 5 to 10. Since movement from one number to the next number covers an angle of 30 degree, it required angle 5 multiplied by 30 is equal to 150 degree. So what we observe here? Your L shape. Whenever you see L shape, it means you have a 90 degree angle, which is right angle triangle. So we see, okay, we have a L shape, which is a right angle triangle. Now we have two numbers between 12 and 3, while they make a 90 degree angle. So we have to divide a 90 degree angle with 3 because it's divided 3 equal parts. Now when we divide 90 by 3, so we will get 30. It means by moving each and every next number we make an angle of 30 degree. So if we want to move towards 5, it means we have to multiply 5 by 30 and we will get our angle measurement which is equal to 150 degree. Now measuring of an angle by a protractor. So this is called your protractor. You can also say it D. We generally say it D just because of it shape we have, this D shape we have, that is why it is also called D. Now a protractor is an instrument in geometry box used for measuring angles. A protractor is semicircular in shape. Its semicircular edge is divided into 180 equal parts. Each part of equal to 1 degree on the baseline is marked the center point. Two scales are marked on the semicircle edge, outer and inner. So this is your inner circle and this is your outer circle we have. Okay. The outer circle 0 reads 0 degree to 180 degree from left to right. The outer circle is reads 0 to 180 degree from left to right, and the inner circle is marked 0 to 180 degree, the same measurement from right to left. So the measurement we have equal 0 to 180 degree, but we read it, the outer will be read left to right and inner will be read right to left. Now to measure an angle, say angle AOB with the protractor, follow this step. So the first step what you have to do, place the protractor so that the baseline is on the arm of OA. So you have to place your protractor like this, your baseline is on the arm of OA. After this, keeping the baseline on OA, adjust it is so that the center point lies on the vertex of A. So what you have to keep in your mind, this center line should be on the your A because it will be help you to measure your angles. After this, read the degree mark on the semicircle edge of the protractor which lies on arm OB. So now you have to see where your lines, this OB is lie. So you should read the scale which has 0 degree mark on the side where point A lies. So you have to read your mark where the 0 degree mark on the side where point A lies. Write the measurement of the angle given by this reading. So now what you see, this ray OA is lies on 60 degree. Okay. So now your angle AOB is equal to 60 degree. After this, we have perpendicular lines. Perpendicular lines, when two lines are intersecting by forming a 90 degree angle. So two lines are said to be perpendicular when they intersect and angle between them is a right angle. And the symbol of perpendicular is this. You can say the reverse of T, it's your sign of perpendicular. It's used to denote perpendicularity. We say AB and CD are perpendicular to each other. AB is perpendicular. We have to use this symbol perpendicular to CD, or we can also say that CD is perpendicular to AB. Okay. If AB is a line segment and P is in a point, so this is an example that if AB is your line segment and P, it's intersecting this line segment at the by forming an angle of 90 degree, it means OP is perpendicular to AB. Now we have our exercise. Or one more thing, OP is a perpendicular bisector of AB. Perpendicular bisector means it is forming a 90 degree angle and as well as it is bisecting your lines into two equal parts. Bi means two and sector means two parts. So this line is dividing into two equal parts with the help of OP, which is forming a 90 degree angle. This means perpendicular bisector. Now we have our exercise 10.2. Classify the following angles as 0, acute, right, obtuse, straight, reflex and complete angles. So this 45 degree is acute angle because it is less than 90 degree. 120 degree, 123 degree is your obtuse angle because it is more than 90 degree and less than 180 degree. 90 degree we all know it is your right angle. Okay. So now what you have to do, similarly you have to classify your angles among the reflex, among straight, obtuse, right, acute according to your above concept. Okay. Now we have question number 2. What is the measure of an angle between north and south? So north and south. So this is your north and this is your south. So we are forming a straight line, or if we are forming a straight line, it means we have an angle of 180 degree. So this is your 180 degree. Now north and east. So this is north and east we have this side. Okay. So it means 90-degree angle. So accordingly, you have to form your figures, and after that you have to classify the angles, your 90-degree, straight angle, reflex angle, and write your answers. Now question number 3, Rishi stands facing north. He turns clockwise through a right angle. North, clockwise means in this direction, right? Through a right angle, okay. What direction does he face now? East. Okay. Aman is facing west, so the same question you have, and right now you have to tell me the direction of it. Now, what kind of angle does the hour hand of the clock move when it goes from 12 to 3? So when we move 12 to 3, it means we are moving, we are making a right angle. So if we are make a right angle, it means 90-degree. It should be divided by 3, and we are forming a 30-degree angle by moving one number to the other. Now, where will the hand of clock stops if it starts from 7 turns through 3 right angles? Timing is 7 o'clock. The first right angle we have this side, the second right angle we have this side, and the third right angle we have this side. It means you can say 6 o'clock should be your timing when we move 7 and turns through the 3 right angles. So it's same, you have to see. First you have to make a clock for your easy understanding, and then you make your turns and you can easily classify it. Then what will be your timing? Where will the hand of a clock stops if it starts at 3 and make 1/4 of a revolution? Revolution means your complete direction. Okay. And 1/4 revolution means 1 by 4 divided by 360 degree. So it means you are making a 90-degree angle. Now you have to move 90-degree when you have 3. So it should be your 6 o'clock again. Okay. It is dependent, you move anti-clockwise or clockwise. If you move clockwise, so then it should be 6 o'clock, or if you move anti-clockwise, then it should be your 12 o'clock. Now, what kind of angle is formed between the hour hand and minute hand of a clock when the clock shows the time 3 o'clock? 90-degree. 5:15 should be your obtuse angle, okay, because it should be lesser than 180-degree but greater than 90-degree. Now our boat is moving towards north, it turns clockwise to the. I hope so, students, this is clear to you. And now what you have to do, you just have to measure the angles, you have to see the questions, and you have to tell by moving your direction, by moving your direction north to west, which angle you are forming. So we move towards your next question, which is which of the following are examples of perpendicular line? Adjacent edge of a book. Yes, you can say, because adjacent edges of a book, it should be like this, where you have a common vertex, and if you have a common vertex, you are forming a 90-degree angle. The letter V, no. Opposite edges of a blackboard. Yes, opposite edges of a blackboard. This, yes, and the letter L. So after this we have our next concept, which is types of triangles. So we are generally classify our triangles on the basis of their angles and sides. Okay, so first of all we study about the basis on the side, and then we are move forward to the classification on the basis of their angles. Recall that a triangle has 6 parts, 3 sides, 3 angles. Triangles are classified on the basis of length of their sides or magnitude of their angles. So triangles on the basis of length of their sides. So first we have equilateral triangle, as the name suggests, equi means equal. So all 3 sides are equal to each other in equilateral triangle. So AB is equal to BC, BC is equal to CA. Next we have isosceles triangle, where we have only 2 equal sides. And which 2 equal sides? Which are opposite to each other. Triangle having 2 sides equal is called an isosceles triangle. In triangle AB is equal to AC. Now we have scalene triangle, a triangle in which no 2 sides are equal to, it's called a scalene triangle. You can also say that in a triangle where all 3 sides have different measurement, it is your scalene triangle. In triangle ABC, AB, BC, CA are having or are not equal to each other. Now triangles on the basis of their angle. Now we are move forward on the classification basis on their angles. Acute angle triangle, it means in a triangle you have all angles which are less than 90 degree. So if all the three angles of a triangle are acute, then the triangle it's called an acute angle triangle. Right angle triangle, if you have a triangle where you see a formation of 90-degree angle, it means it is a right angle triangle. If one angle of a triangle is a right angle, then the triangle it's called a right angle triangle. Okay. Next we have obtuse angle triangle, where in a triangle we have one angle which is greater than 90 degree. It is called your obtuse angle triangle. If one angle of a triangle is obtuse, then the triangle is called an obtuse angle triangle. Now we have our exercise 10.3. Define the following terms. So we already do these terms in our above section, so I can't help you. You have to go there, read the concept and write the answer. What is a scalene triangle, right angle triangle and obtuse angle triangle. Now classify the triangles given below on the basis of their sides. 5 centimeter, 5 centimeter, 3 centimeter. It means two sides are equal to each other. It means it is a isosceles triangle. Triangle DEF with D is equal to EF, EF is equal to DF. Both all three sides are equal to 7 centimeter. It means it is an equilateral triangle. So accordingly, you can also classify between your angles by seeing their side measurements. Now we have to classify the triangles given the below on the basis of their angles. So we have 50 degree, 75 degree and 55 degree. All three angles are less than 90 degree, which means acute angle triangle. So it is an acute angle triangle. Now triangle with the angle 90 degree, 30 degree and 60 degree. If we have one angle of 90 degree in a triangle, it means it is a right angle triangle. So similarly, you have to answer the following questions as I do. Now we have types of quadrilaterals. You have learned in the previous chapter that a quadrilateral is a polygon with four sides. In this section, you will study different types of quadrilaterals. So in making these quadrilaterals, two or more set squares will be used. The three angles of one set square are 30, 60 and 90. And the three angles of second set square are 45, 45 and 90 degrees. So what you see here, we have first rectangle. Quadrilateral means a shape which have four angles and four sides. Okay. So we all know that rectangle has four angles and four sides. So similarly, we have different quadrilaterals which we are going to deal in depth in this section. So place 30 degree, 60 degree, 90 degree set squares as shown in the given figure below. So you have to set these squares like this, and what you see here, that opposite angles are equal to each other, diagonals are bisecting each other, and each angle is equal to 90 degree. Next we have square, place two 45 degree, 45 degree and 90 degree set squares as shown in the figure below. The quadrilateral thus obtained, it's called a square, which means all four sides are equal to 90 degree, all four sides are equal to each other, opposite sides are parallel to each other, opposite side because all sides are equal to each other. So opposite sides of a square, the two diagonals of a square are equal, and the two diagonals of a square bisect each other by forming a right angle. Now we have parallelogram, so you have to place your squares like this, and in parallelogram opposite sides are parallel and equal to each other, and two diagonals of a parallelogram bisect each other. Next we have rhombus. So you have to place 30 degree, 60 degree and 90 degree set squares as shown in the figure. The quadrilateral thus obtained, it's called your rhombus. In rhombus, as square, all four sides are equal to each other, opposite sides are parallel to each other, and diagonals of a rhombus bisect each other at a right angle. So next we have trapezium. In trapezium, place 30, 60 and 90. The quadrilateral that you get, it's called a trapezium. In trapezium ABCD, opposite sides are parallel to each other and a pair of opposite sides are equal to each other. Next we have opposite sides. Opposite sides are not equal to each other. Opposite sides of pair of opposite sides is parallel to each other. Now we have exercise 10.4. Which of the following statements are true? Opposite sides of a parallelogram equal and parallel to each other? Yes, true. All the sides of a rectangle are equal? No. All the sides of a rectangle are not equal. Diagonals of a square are not equal? Wrong. So in same way, you have to read out these statements and classify among true and false. Now question number 2, name the quadrilateral in which Opposite sides are equal and parallel. You can say parallelogram. Diagonals are equal. You can say square, rhombus. All the sides are equal, so square, rhombus. So in same way you have to answer the rest parts. So in same way you have to uh, write the answer for the following parts. Now give reasons for the following. Every rhombus is a parallelogram. Every rhombus is a parallelogram because in rhombus we have opposite sides parallel to each other, right? So in parallelogram what we have to mention that opposite sides are parallel to each other. So this condition is fulfilled by your rhombus. That is why we can also say that a rhombus is a parallelogram. In same way you have to give the reasons for rest of the parts you have in question number 3. Now we have more about polygons. We get more knowledge about the polygons. You have learned about triangles and quadrilaterals. Polygons with 3 or 4 sides. Now you will know about polygons having more than 4 sides. In any polygon, the sides may or may not be equal. You have studied equilateral triangle where all the sides are equal, and also scalene triangle where all the sides are not equal. So you know about squares and rhombus where all sides are equal, whereas in parallelogram, rectangle where all 4 sides may not be equal. So a polygon, it's called a regular polygon if all its sides are equal and all its angles are equal. So regular polygon means there are two conditions. It should be have all equal sides and all angles are equal to each other. So we have some regular polygon like pentagon, hexagon, heptagon and octagon. Okay. After this, we have exercise 10.5. On the basis of number of sides, name of the following polygons. 1, 2, 3, 4. So we have 4 sides and it is parallel sides are equal to each other. So you can say it is a quadrilateral as well as a parallelogram. 1, 2, 3, 4, 5, 6. So it is a hexagon. So now you have to count the sides of your figures or polygons and write their name. Draw a rough sketch of a pentagon. Also draw its diagonals. How many diagonals does a pentagon have? So you can do that, right? You have a pentagon here, okay? Or you can make it. Now each of the following figures is made up of 6 line segments. Are they hexagon? Give reasons. In hexagons, what we understand, hexagon is a regular polygon. Or in a regular polygon, we have all 4 sides equal to each other and all 6 sides are equal to each other and all 6 angles are equal to each other. But in this, what we see, all 6 sides are not equal to each other, or not all 6 angles are equal to each other. That is why these are not your hexagons. Now we have 3-dimensional shapes. 3-dimensional shapes means 3D shapes. Till now we learnt about the 2D shapes. We have rectangle, square, rhombus. These are the 2D shapes. Till now we have discussed geometric figures on a plane. In your surroundings you will find geometric shapes which are not flat. For example, a box, a ball, an ice cube, a pencil, etc. These objects are not shaped flat but solid, or you can say the 3-dimensional. Some of the 3-dimensional shapes are cuboid. A cuboid is a solid figure bounded by 6 rectangular plane figures. So this is your cuboid. In 3D shapes we have 3 things: face, edge and vertex. Each of the rectangular plane regions is called a face of the cuboid. The figure below shows the cuboid 6 faces: A, B, C, D, E, F, G, H, A, B, E, H, D, C, F, G, B, E, F, C and A, D, G, H. We mentioned 6 rectangular plane regions. So there we have 6 names of the rectangle. Thus a cuboid is like a box with rectangular sides or faces. The line segments where 2 faces meet each other is an edge. A cuboid has 12 edges. In the given cuboid, edge A, B, B, C, C, D, D, A, etc. And the point where 3 edges meet is called vertex. And your vertex is A, B, C, D, E, F, G, H. So this is your vertex. This is your faces. And where these 2 faces are meet together, this called your edge. Now next we have cube. In cube we have 6 squares. So a cube is a solid bounded by 6 squares, 6 square plane regions. The adjoining figure shows a cube. It is like a box with square faces. For example, sugar, cube, dice, etc. A cube has 6 faces, 12 edges and 8 vertex, just like your cuboid. Next we have cylinder. A cylinder is like a circular pipe. In a daily life, you come across many cylindrical shapes, circular pillars, measuring jars, glasses, circular electric poles, etc. A cylinder has three faces, two flat faces and one faces which are circle and one curved face. It has two curved edges. We total have three faces in a cylinder where two are flat and one is curved and two it has two curved edges as well. Next we have cone. An ice cream cone, joker's cap, funnel, sharpened end of and a pencil are in the shape of cone. A cone has two faces, a flat face forming base of the cone and a curved face. So the flat face of a cone is a circle. A cone has one vertex and one curved edge. Next, sphere. A ball gives you the shape of a sphere, a tennis ball, a marble, football, or examples of a sphere. A sphere has only one face which is curved. Next, we have pyramid. A pyramid is a three-dimensional shape with a base which may be a triangle, square, or any other polygon. The other face of pyramid are triangles meeting at common vertex. So, if we have a base of triangle, so that is your triangular pyramid. A pyramid whose base is triangle, it is called a tetrahedron. It has four faces, six edges, and four vertex. Prism. A prism has two identical bases, may be triangle, rectangle, or some other polygon. The other face of the prism are rectangles whose number depends on the base of the prism. Our prism is named according to the shape of its base, triangular prism, rectangular prism, etc. Now you have your 10.6 exercise. Write the name of the following shapes. So no, this is a cube, it is a cone, this is cylinder. So you have to write their name. Write the shape of each of the following object. A book is a cuboid. A joker cap is a cone. A marble is a sphere. So इसमें cylinder. So you have to write your answer for rest two parts are there. Now how many faces do the following figures have? Cylinder, three faces. Sphere, only one curve. Cube, we have six faces, right? So, no, 12 faces in cube. True. So, in cylinder we have three and in sphere we have one. So, accordingly you have to write your answer for rest of the following. Write the number of faces, edges and vertex of, so cuboid, 6, 8 and 12. So, similarly you have to write your answer for rest of the figures you have. After this is the end of your chapter and here you have things which you have to keep in your mind. So these are the concepts which we learned in this chapter. I hope so students this chapter is clear to you and you understand this and you understood this chapter very well. Now I'm going to meet you in your next class. Till that, bye bye. Have a good day.